Section 6.6 on page 703, where we have moments and centers of mass. What are they? It doesn't matter. Okay, these are concepts of physics, and we don't care what they are. It's just look at the theorem on the following page, which lets you calculate what the moment is and what's the center of something, center of mass is. So go ahead and look at that formula, and never mind where it comes from or even what it means or why it's true. It's a concept of physics, and we are not going to go into it. So please do example 6.29. You don't have to understand what it means to just plug stuff into the formula and come up with some answer. And that's what you should do. And in fact, for this entire section, please simply do all the examples as homework. That way, if you don't know how it's done, the explanation is right there. And after that, we will get back to calculus again, okay, where we'll study logarithm next section, not center of mass. Yeah, if it was up to me, I wouldn't even cover this stuff, but we need to respect the book, so I will talk about it. So please do example whatever it was before, and then the next example 6.30. And these examples don't even have calculus in it. So I don't know why we're doing that. But okay, next page 707, the symmetry principle. That's again a point in physics, which says the center of gravity, also called the centroid, in physics, is on the symmetry line. The center of gravity is something that if you were to balance the object on your finger, like this object I have here, if you were to balance it on the finger, as long as you go through the center of gravity, the thing will theoretically perfectly balance. That's the center of gravity. Well, whatever. The center of gravity is in the symmetrical point, if the object is symmetrical. Next on page 708, the center of mass is given by some formula because of various reasons. The reasons are the same as what we've been saying this whole time. Okay, you you do the Riemann sum, multiply it by delta x, and then you come up with some formula. And you're multiplying based on physics principles, which we're not going to explain here. Okay, that I will be doing the physics class because the Openstax has a free physics textbook as well, so I'll be doing that one in the future after I'm done with all the math. And then so if you're interested in physics, please take that class and then and so we're not going to be stuck in here with physics because this is a calculus class. So look at those formulas, and then the formulas are very straightforward. And for the homework, then examples, you just plug the appropriate function into the appropriate formula, and out pops your result. So keep going, turn the page. Center of mass bounded by two functions, same idea. Okay, if it's bounded by two functions, you subtract them, and then follow the formula and come up with some math. So that's example 6.32. Please do that example, okay, out of respect for your book. But I'm not going to do it because I don't like grunt work. This is all grunt work, okay? For us, because we're doing calculus. This is just algebra. So it's all grunt work for us. But you should do some grunt work because it's good to build character. Okay, all grunt work, suffering is good for the character and stuff. So you're gonna get a ton of character out of this section. And next, the symmetry principle, 6.33, same idea. And that's about it. And then there is even a theorem of purpose for volume, which sounds interesting until you realize that it doesn't really do much. So we're gonna skip that. Okay, I don't find it that interesting because that one you can use it to calculate the donut, but otherwise I'm not sure where the benefit is, so we're gonna skip it. And being that it's only in the project, so yeah. So with that, we get to the end of the section of 6.6. So please do the homework, and which are all the examples, and that should be good enough for anybody. Well, it's definitely good enough for me. And let's move on to the next section.